going to record it now. And so my name is Mr. Bing. This is Project Lead the Way Course 2, which is Principles, POE, Principles of Engineering. And I'm going to do or talk about a little bit of the activity 2.3.1. My class is here. They might be listening or not, and I'm fine either way. If you want to listen, that's great. If you don't, that's okay too. If someone's at home listening to this is really more of a test for me than anything else. But I might be able to give some instruction. What you see on, I guess if you're looking at both, right? If you're looking at my screen and me, if you're looking at my screen, which is the 231 stress strain calculations, and then procedure and notes and everything until we get to this point. If you can see problem number 1, which we did in class, and problem number 2, which we're going to do right now. And then what is on the notebook screen, I don't know why I'm pointing. You can't see me pointing. On the notebook, little mini screen, there's the work that I'm about to do. And you see the notes that I've already done for this assignment. Let's see, notes, lots and lots of beautiful notes, and then some more notes. And then finally, I get to some blank space on the paper. And I haven't done number 1, and so I don't care. I'm just going to do number 2 right now. So it says a 1/4 inch diameter rod. I'm going to write that down. A diameter G equals. It said. Did it say 1/4? I prefer decimals. 0.25 inch diameter rod must be machined on a lathe, which is sort of like have you seen the pottery wheels? A pottery wheel, you put a big giant wet piece of clay on it and it turns and you mold it. Well, a lathe is similar. It goes sideways though. You take a piece of metal and you put it on this thing that spins, and then you can use tools to cut the shape. That's what a lathe is. So there's a rod, a 1/4 inch diameter rod, must be lathed, or must be I don't know what to call it. Has to be changed to a smaller dimension. So this dimension is going to become smaller. I don't know what that will be, but it will be smaller. And let me see, a 1/4 inch diameter rod must be machined on a lathe to a smaller diameter for use as a specimen in a tension test. Tension, by the way, tension is when you take a piece of something and pull it apart. That's what tension is. The rod material is expected to break a normal stress of, okay, stress, I don't remember the variable for stress, but I'm looking at my notes and I see it. The stress is the sigma. That's a sigma. I'll make my little screen bigger when I'm ready to go. The normal stress is 63,750. 63,750 PSI. PSI is pounds per square inch. So keep in mind, we're working on pounds and we're working in square inch. And so the inch that we got in diameter, that looks good. That's good. And then it says, if the tensile testing machine can apply no more than 925 pounds of force. Okay, that's an F. That's an F. 925 pounds. 920, LB is pounds. I think that's from the Latin. 925 LB for pounds of force to the specimen. Calculate the maximum rod diameter that should be used for the specimen. What? Calculate maximum. D is diameter. They already gave us a diameter, but this is a max. I don't know what that means. Okay, let me think about this. I'm broadcasting this to the world. I'm recording it, and I'm saying it right to you live. This is all very nerve-wracking because I don't know exactly what the question is asking. Calculate the maximum rod diameter that should be used for the specimen. A 1/4 inch diameter rod must be machined on a lathe to a smaller diameter for use as a specimen in tension. And then it says, calculate the maximum. I got it. Okay. So this is I'm going to make this big now. How do I do that? Stop share. And then do this. Is that working? Full screen? Oh, no, not that. Oh, yes, that. Why is there a screen within a screen? How do I get rid of that? Okay. here's what's happening. This diameter is what we want. No. This diameter is what we start with. This diameter is what we want to get. The fact that they call it the maximum diameter confused me because I thought that doesn't make sense. It's going smaller. If it's going smaller, how is that a maximum? And what that means is that, yes, it's going to go smaller, but how much smaller? If this is the cross section, if that's the cross section of it, and it's going to go that small, well, what's the maximum that will still satisfy all these numbers? I have no idea what I just said, but I will look at some equations. I have a diameter. I have, what is that, a stress? And that's a force. And I'm looking for, let me see here, a diameter and a force and a, well, here's a stress. Stress equals F over, what is that? Is that an A? Okay, I don't know what to do. So I'm just going to write down that equation. And by the way, when it said, Adam, about the 5-step process that I told you to ignore, the 5-step process is, of course, GUESS really is all you need to remember. The given. We have already written down the given. It is all right there. It's good. Now the unknown. Well, the unknown is this diameter max. And then the equation that we have arbitrarily chosen, because we don't know what else to do, is F over A. So they gave us the stress. Boom, we got that. They gave us the force. Yes, we've got that. Well, they didn't give us the area. So we're trying to solve for area then. That's not really what they asked us to solve for, but I kind of know already that if I solve for area, then I'm going to be able to solve that for diameter. Does that make any sense? Maybe it will. Fake it till you make it, Cody. Remember that. Do that. Fake it till you make it in engineering and in physics and in life and in relationships. No, you don't like that? Okay, so I've got the given and the unknown in the equation. And now I'm going to look for substitution and solution. However, I'm going to suggest you do a little bit of algebra first before you do any substitution. And there's some easy algebra. I hope you agree this is easy. There's some easy algebra here. I can just switch those. And I get, what do I get? A equals F over sigma. Please catch my mistakes because of the recording and the broadcasting and the live presentation. It's all very nerve-wracking, and I'm going to make mistakes. So catch my mistakes. A equals F over sigma. The F value, what was the F value? 925. And what was the sigma value? 63,750. Okay, so I guess there's going to have to be a number there. So A equals, hey, where's my phone? Okay, hey Siri, what is 925 divided by 63,750? Okay, Siri said that it is, can you see that on the screen? Okay, I guess that's right. I mean, you can check my math if you want. However, that area is square inches. That area is square inches. And we weren't asked for area, we were asked for diameter. So okay, all right, we're asked for diameter. I'm pretty sure there's a way to turn an area into a diameter. This is a circular cross section. A diameter obviously is a function or a characteristic of a circle. So if I remember the area of a circle, what's the area? Area equals, is it pi r squared? Pi diameter squared or pi r squared? For the area of a circle. Okay, so there's two different versions. One of them is for the R, one of them is for the D. Okay, and by the way, Kevin was trying to give me the other version of it because we're looking for a diameter. So why wouldn't we use the equation that has a diameter in it? And my answer to that is I'm more familiar with this one. And then once we find the radius, we'll just double it to get the diameter. Okay, so a little bit of algebra again. R squared is being multiplied by pi. So if I divide by pi, I can just get R squared by itself. So R squared equals A divided by pi. All right, that's nice. And then that is equal to, we just got the A value of 0.0145 divided by pi. I'm just going to use 3.14. And then what's that going to equal? Hey, Siri, what is 0.0145 divided by 3.14? Okay, can you see that on the big screen? Okay, 0.004617. Please check my math. Now that, by the way, is not R. That is not R. Well, what is it? It's R squared. So in order to get R by itself, I'm going to have to square root that. Hey, Siri, what is the square root of 0.004617? Okay, she said a lot of digits, and I kind of got lost. So I just got the first three digits after the decimal, 0.068. That is the radius in inches. Again, that's not what we were asked to find. We were asked to find the diameter. There's got to be an easy way to turn a radius into a diameter. Hey, Siri, what is 0.068 times 2? And that's inches. Okay, so I'm sorry I ran out of paper. But the point here is that assuming that my calculations are correct, that I didn't make an error when I was either saying something to Siri or reading something from Siri or listening to something from Siri, assuming all the math is right, 0.136 inches does make sense because it said you start out with 0.25 inches and then you lathe, L-A-T-H-E, you lathe it. And when you lathe it, it gets smaller. And so how much smaller did it get? 0.136. And you might be saying, well, I thought the diameter was a maximum and this is smaller than 0.25. Well, the point is that how small do you have to go before it's too small? And the answer is 0.136, because any smaller than that, the piece of material will no longer have the strength to do whatever they're wanting it to do. And I don't remember what that is. But I feel pretty good about this. I hope this kind of makes sense. I'm going to sign it now. I like signing. Here's my signature. I hope you're impressed. There, that's me. As you get older, your signature becomes more and more challenging. And then I'll ask Cody to witness it in just a moment. Oh, today's date, what is it, 11/19? Okay, so that's it. I'm going to stop the recording now. I don't know if I should switch back to my face or not. Probably not. You don't want to see that. So I got to pause or stop. I got to do something. Nothing's working. Okay, bye for now.